Moncoiffé. She comes from BODC, is a biological oceanographer who specializes in scientific data management and leads the team responsible for managing the NERC vocabulary server. I know a lot of you will be interacting with NERC, so we'll get to hear from Gwen about building a pipeline for biodiversity data from the BODC, which is the British Oceanographic Data Centre, to OBIS, the challenges and the opportunities.
Thank you very much. So we can go straight to the first slide. Next, please. So I just first wanted to present you BODC for people who don't know. We're a national marine data facility operated by the National Oceanographic Centre with offices in Liverpool and Southampton. BODC has many national and international collaborations within the marine domain, but also across other domains in the environmental sciences. It is one of 5 dedicated NERC environmental data centers covering the marine, the atmospheric, the polar and cryosphere, the geoscience, and terrestrial and freshwater domains. It is one of 7 accredited data archive centers for the Marine Environmental Data Information Network, MEDIN, in the UK. BODC is a key partner in the CDataNet and EMODNet network in Europe. It is also the UK NODC within the IOC-IOD network. BODC operates the NERC vocabulary server, NVS, whose vocabularies are used in many national and international marine data systems. Next slide, please. So this slide shows an extract from a poster I actually presented at the Color of Ocean Data in Brussels back in 2002. This was the first time that such an overview of biological data was done for BODC data holding. For a long time, it was mainly BODC, like many NODCs, was not initially required to deal with biological data. And for a long time, it was mainly dedicated to the curation and quality control of physical oceanographic data measurements. However, the launch in the 90s of large national and international research programs, multidisciplinary research programs, like, for example, GGOVS or IMBER, created the need for data systems that could cope with both biological, or could manage biological data alongside other measurements collected on research vessels. So BODC started developing its data infrastructure and also developing new control vocabularies to support data and metadata harmonization across these multiple new data types. Next slide, please. So BODC started submitted species occurrence data to OBIS back in 2006. However, the lack of adequate support for associated quantitative data at the time was an issue for plankton datasets. The same year, we asked Vlees to kindly set up an IPT instance for us with a view of starting more regular submissions of ad hoc datasets, but lack of resources at the time and opportunities for this work meant that the IPT remained empty for a long time, until recently. In 2017, we were also, we contributed to we were involved in the working group work that led to the extended measurement of fact extension to OBIS, with the outcomes that was published in the paper by De Putter et al. This work was really seminal in enabling OBIS to handle quantitative measurements. So when an opportunity came last year to actually, well, when an opportunity came, we took that opportunity and we responded to the call from the European DTO Bioflow program and applied for funding to finally establish a regular data submission pathway from BODC to OBIS. Next slide, please. So the DTO Bioflow, you could go through the 5, yeah. The DTO Bioflow proposal had 5 main goals: to develop staff skills and knowledge about biodiversity data management in ocean sciences. There's too few of us at BODC who can actually understand those data. To build a crosswalk between BODC databases, vocabularies, and the OBIS Darwin Core Archive format. To identify the optimum workflow between BODC, the UK OBIS node at the Marine Biological Association, and also to to EuroBIS and Emonet Biology, to publish our legacy species distribution data alongside abundance and any other quantitative data that comes with it, and to become a regular contributor of data to OBIS as well. Next slide, please. So it is always interesting to see how much different data systems have in common, but also how difficult it can be to align them, especially when dealing with legacy assets. The biodiversity samples database was built to support publication of multidisciplinary research projects as an integrated dataset published on CD-ROM. It was developed by Royal Array and first tested with the NOCI project. So it's going back in the 90s, early 90s, but went through a number of iterations after that. At its core is the data collection event table, where spatiotemporal information about the data collection event is kept. It is connected to a fieldwork metadata table, where the cruise level information is managed, and it is also connected to a simple sampling gear metadata code list table. From the data collection event, a number of branches allows us to deal with the various metadata requirements that may be associated with different types of sampling gears, but like bottle sampling, plankton and net sampling, sediment core sampling, etc. Next slide, please. So in order to avoid data silos and minimize redundancy, the differences between the data types are kept to a minimum, and each branch of the metadata table is coupled with a data table whose normalized structure is the same across the multiple data types. These data tables have identical fields, and each measurement record as a unique sample ID, a parameter code, a measurement value, a unit code, a QF flag, linked to a documentation, free text documentation, a data originator, and a unique measurement ID. So all those fields were used to create the crosswalk between biodiversity databases and OBIS. So after sketching the crosswalk, a series of complex SQL menus were built to harvest data and metadata from the biodiversity database and distribute the information into the OBIS schema XML metadata file, as well as the 3 Darwin core file types for event, occurrence, extended measurement of fact. This process required extensive iterative checks by a core team of 4 data managers and some manual editing as well, to ensure that the information was complete, consistent, and of a quality acceptable for external publication. Next slide, please. So one of the challenges that was actually to convert our own P01 parameter code to parameter codes compliant with the OBIS recommendation. And this may surprise many, but I will need to explain a little bit why. So as many of you know, the label of the P01 parameter is made of the concatenation of concept structured by a semantic model. But put simply, it is a property of a target object in relation to a matrix by an optional method. So for physical parameters, the target object and the matrix can be the same. And like, for example, you've got practical salinity of the water body, temperature of the water body. Next, please. If you could click again, please. So, but for chemical and biological parameter code, we store the object. The target object is actually the name of the targeted either chemical or biological organism. So this means that for our biological parameter codes, we've actually got the name of the species within the P01 parameter code. Like, for example, you will have abundance of Skeletonema costatum per unit volume of the water body, or you will have biomass as carbon of euphosids per unit area of the water body. Next, please. So in order to complete the crosswalk, we had to extract the species name from the P01 semantic model and place it in the appropriate field in the occurrence record, while the associated measurement value is copied to the extended measurement of fact record, and the measurement type ID is populated with a generic OBIS compliant P01 code. Next slide, please. So I will just leave that slide out, and if you have questions about it, just ask me afterwards. So building the pipeline and workflow. So to finish, towards the end of the project, the team was joined by developers to help develop a semi-automated pipeline using Python, code scripts, and a workflow management. And this will be used to manage future data submission to OBIS UK and EuroBIS. Next slide, please. So the key decision in the course of this project, we had to make key decision, which was to attribute DOI to legacy data, to expose data at a granularity that enables us to easily manage the workflow going forward, but as well for the legacy data, to keep our IPT instance at Vlees instead of using the UK node instance. And this is to save time, but also same time during the project, but it was also to minimize, sorry, can you come back again, please? It was also to minimize a disruption if we decided to host our own IPT and add functionality to the existing workflow. Next slide, please. So the key outcome was that we trained 4 members of staff to champion biodiversity at BODC. We documented a crosswalk between the 2 systems. We built that semi-automated pipeline, and we exposed 15 datasets from 4 research projects, and 30 more are actually waiting to be published. And we also welcome the opportunity to work more closely with colleagues from the OBIS network, and in particular in the UK and in Europe. Next slide, please. So just finally, just to wish to thank the team involved at BODC for all their hard work and dedication in this project, and also thank colleagues at Vlees and the MBA for advice and feedback. And this work wouldn't have been possible without the direct funding from DTO Bioflow, to which we are very grateful. Thank you very much.